You're listening to the Building HVAC Science Podcast, the only podcast where you can BS with BS about BS. Here's your host, Bill Spohn.
Hello, and welcome to the very first episode of the Building HVAC Science Podcast. This podcast is a part of the Blue Collar Roots Network. I'm your host, Bill Spohn. You may know me or know of me, but let me give you a little bit of background. I'm the president and co-owner of TruTechTools, and my background is in engineering, but please don't hold that against me. Hopefully, I'm one of those engineers you can get along with. I've been working in the HVAC industry since 1988. 10 years with Testo, 10 years with Bacharach. Sandwiched in there was 2 years with Superior Valve Company, and most recently, I've got over 8 years with TruTechTools. Through that experience, I got to learn an awful lot about building science and the HVAC trades. I think everyone's in general familiar with HVAC, heating, ventilation, and air conditioning, but people may not be as familiar with building science and what that's all about. A very technical definition of building science is the collection of scientific knowledge and experience that focuses on the analysis and control of the physical phenomena affecting buildings and architecture. Whew, that's a mouthful. And this definition I'm reading goes on to explain it includes areas such as building materials, building envelope, heating, ventilation, and air conditioning systems, as well as electric and natural lighting, indoor air quality, passive strategies, fire protection, renewable energies. It kind of goes on and on. There's an awful lot to discuss here. We're going to focus an awful lot on the heating, ventilation, air conditioning systems performance, as well as the building envelope. Really, to borrow a phrase from my friend Dave Richardson from NCI, the building envelope is really the missing part of the duct system. It's what connects the supply to the return. That's a very interesting concept if you think about it. Certainly, we'll also talk about indoor air quality and an emerging type of market called the healthy home environments. There's a lot of activity going on there at this point, and we're going to learn about that as we go through our series of podcasts. Okay, so why the odd name? Why building HVAC science and not building science and HVAC? Well, there's another aspect to this. I want to try to help build your understanding of HVAC science. That's where the building HVAC science comes from. And the building science is sort of wrapped around HVAC. It's embedded in it. It's part of the definition. I give a lot of presentations around the country with regard to building science and HVAC, especially the test and measurement aspect. And when I do so, one of the themes I kind of focus on is the theme of making and controlling expensive air. Because that's really what HVAC systems do. They make air the way people want it. It's comfortable, it's clean, it comes in the right place at the right time, at the right temperature, with the right humidity level. And if that's not present where people want it to be, it will sometimes cause discomfort or displeasure. So making and controlling expensive air is really what I think HVAC is about. When you encounter factors like other sources of pollutants in the home, duct leakage, air leakage, leakage through the building shell, well, that really impacts that expensive air you've created. So that's my vision on how HVAC and building science actually tie together. Okay, let's circle back around to what is the Blue Collar Roots Network. Well, the Blue Collar Roots Network is made up of a series of podcasts. The HVAC School podcast is one of them, HVAC Shop Talk, HVAC Tool Pros podcast. Now, you may be familiar with some of the people involved with those podcasts. Brian Orr, Zach Ciota, Ralph Wolf, Brent Ridley, Billy Noth. Maybe a new person to you is Tersh Blissett, and Joel Testerman will also be doing and bringing in a podcast of his own shortly. The objective of these podcasts, as Brian Orr so eloquently put it, is to really improve the trades and elevate the professionalism of the trades. Now, hang on a second. You might be a little bit worried that how can this engineer be part of a Blue Collar Roots network? Where's his blue collar? Both of my parents were blue collar workers. My dad is a letter carrier, and my mom was a switchboard operator. My grandparents were also blue-collar workers. My grandfather actually worked in the sulfur mines in Sicily and the coal mines in Pennsylvania. Got a number of topics in mind to cover and a number of guests that I'd like to bring on the program. But certainly if you think of something you'd like to hear about, I'd love to be able to provide that for you. I'll do my best. Probably the best way to reach me right now is through a Facebook page, which just launched a few days ago. You'll find it under, of course, Building HVAC Science Podcast. That's the way you'll find the Facebook page. Please leave a message or a note there. It's very interesting for me to see that only after a few hours, I'd say less than a day, we're over 160 people liking and following the page. So there must be some interest in this topic, and I've got a lot of good commentary generated from that. Some of the topics I'm looking at exploring are topics like a dozen ways to measure airflow. Blower doors, what are they good for? Why HVAC and building science go hand in hand. I like to bring in some guests that have a little bit richer experience to share with you. Also, one of the topics that came up from the Facebook page mentioned was mean radiant temperature. Now, raise your hands out there. How many people are familiar with that and what kind of impact that has on the work that we do? I've also had the good fortune to work with a number of good builders that are using advanced topics and advanced techniques in designing homes and integrating HVAC systems into the home. Now, how often do you feel like HVAC systems get kind of short shrift? They're usually one of the trades that ends up getting compromised in the process of building and constructing a home or in a renovation. So we like to be able to be sure that the information you have with regard to building science and HVAC can allow you to sort of defend and understand what's happening when changes are made to the plans. We'll also be talking about the science of combustion analysis, why and what is CO air-free, carbon monoxide air-free. We'll be talking about duct leakage and other topics like energy rating and home energy rating. There's a lot of interesting things going on right there, and I had a couple conversations last week that I'm sure will generate some guest speakers on the podcast. Earlier, we spoke about healthy homes and healthy environments. That's a really new frontier, and I think that's something that would be of interest to people on the podcast, and we'll have some guests brought in from that, some technical topics there, as well as business topics. Really, how do these things all relate together? How can they be integrated into a business? You may have also heard of passive houses or net zero homes. That's a topic that's actually of personal interest to me, and I'd like to be able to share some knowledge and some background on that with some guest speakers that I'm planning on having aboard. So one of the products I want to talk about right now, something you may or may not be interested in, is a book that's called HVAC 1.0. And I have developed from this book a presentation which I give at a variety of conferences around the country during the course of the year. And I'd like to get into a little bit of what that covers. Now, if you're a technical pro in the HVAC field, you may feel this is a little bit underwhelming for you, so you could tune out right now, or maybe just want to listen in and see what I'm going to talk about. But the premise of this book is to give an introduction and overview for people who have little or no experience with HVAC. And that would be people you're working with in sales, architecture, energy rating, building performance, code enforcement, utility programs, energy consultants. Give them a better idea about how systems work. So if you're not dealing with HVAC systems on a daily basis and you want to feel comfortable, get familiar with the jargon. That's what we've done through this. Actually, Russell King has done through this book and what I have done through the presentation I've created from it. Now, the HVAC system, from this in my eyes, so we're going to call this HVAC 101 BS style. And that could be building science, Bill Spohn, or maybe another phrase comes to mind when you think of BS. But there's an awful lot going on, a lot of respect I have for the practitioners and professionals that work in and around HVAC systems. There's things like energy changes going on. There's changes in temperature and humidity of the air that's going in the system. There's fuel pressure, fuel leakage from the fuel service if this is a fuel supplied appliance. Definitely electrical measurements are going on for distribution air, for duct systems, the AC, the condenser, the controls that go on, system pressures, temperatures, the CFM, the airflow, duct pressures, duct leakage, electrical service, and that's only in the HVAC system. Now let's take a little bit more broadly and look at the building parameters that are outside of the box. Things that you would measure with, say, a blower door, the air leakage through the shell, thermal imaging, thermal transfers and thermal leakage, and load calculations, things that consider as a system actually being set up, designed correctly to handle the load that's being imposed upon it. One very critical aspect that comes up is with regard to airflow measurement is fresh air, having the right amount of fresh air to supply the air that's being pulled out of the environment, maybe through a kitchen range hood, through a bathroom exhaust fan, through other forms of exhaust fans that are inside the structure. So there's mechanical ventilation going on. There's also system airflows, supplies and returns. So airflow has a lot of different connotations to it. So one of the things I'd like to focus on if we're looking at HVAC 101 is some of the terminology. Things like what's a BTU? It's a British thermal unit. It's the energy required to heat 1 pound of water 1 degree Fahrenheit. Now, when we talk about BTUs, that's the energy required, but usually we're talking about an energy rate, BTUs per hour or BTUHs. Some people use shorthand. That's not exactly correct, calling it a BTU for a system energy conversion, but we're going to talk about it correctly here. BTUs per hour is really the terminology you should use. Now, we're all familiar with, or likely familiar with, tons of cooling. So that's 12,000 BTUs that are conveyed in an hour's time. That's 1 ton of cooling. 1 ton of cooling was derived from the fact that it melts a ton of ice, or an ice cube, in 24 hours. Now, that ice cube is pretty big. It's not going to fit in any glass that I know of. That ice cube would be 39 by 39 by 39 inches. So that's a ton of ice. Melting that in 24-hour period, that will give you 12,000 BTUs. That's where tons of ice comes from, or tons of cooling comes from. So there's more terminology involved. There's some of the different organizations that actually set standards. AHRI is the Air Conditioning, Heating, and Refrigeration Institute. Now, that used to be 2 organizations, one called GAMA, the Gas Appliance Manufacturers Association, and AHRI, the Air Conditioning and Refrigeration Institute. I actually took part in a GAMA committee meeting, a committee that developed the current combustion analyzer standard, which you may be hearing a little bit about. It's now called AHRI 1260. So we actually might do a little show on that at some point, give you an idea of what went into that. The various combustion analyzer manufacturers got together to discuss what would be a good normal standard that could be used to evaluate the performance of combustion analyzers. There's also Seer. Now, Seer means the Seasonal Energy Efficiency Ratio. Now, that's tested over a season of conditions, so it isn't something you can actually develop or measure in the field at any one point in time. However, EER, which is the Energy Efficiency Ratio, that doesn't have the seasonal in front of it, the S in front of it, that can be tested at one condition at one point in time. So that's something you can actually test with some of the new equipment out there. Other terminology you may hear about is AFUE. That's the Annualized Fuel Utilization Efficiency, and that's for furnaces. Again, because it's annualized, it takes into account various factors across the seasons. That's, again, something that you cannot do except for a lab test. There's also the heating, the HSPF, which is the heat pump season performance factor. That would give you an idea of the seasonal performance of a heat pump. Another term we run into a lot, of course, is FPM, or feet per minute. That deals with air velocity. That's just the speed of the air. CFM is another term we run across a lot. That's cubic feet per minute. That's volume flow. That's the velocity measured over a cross-sectional area. So when we get into our airflow discussions, that's going to be something that comes up very often. Is actually, sometimes we just measure velocity, but we have to know the cross-sectional area of the flow in order to be able to tell what the actual CFM is. Next, talk about controls. Things like thermostats for controlling temperature, humidistats for controlling humidity, something I like to call humanistat. Things like people adjusting the environment that they're in, maybe adjusting the thermostat, maybe opening and closing doors, windows, doing different things that change the environment. Those are sensors that are impacting a human that make them feel that they need to do something different to control their surroundings or conditions. This happens to have a very large impact, and some of the things that impact people themselves for comfort are things like mean radiant temperature and also the humidity level. There's something called the Ashrae comfort zone you may be familiar with. That's a range of temperatures and humidities through which people feel generally pretty comfortable. Another factor to consider is the mass of the furnishings. The furnishings inside an apartment, inside a building, inside a home, that can have a very dramatic impact on the humidity absorption and rejection from these materials, because you have to basically dry the surroundings out before you can start to drop the actual humidity that's in the air. So that can have an impact for both temperatures and humidities. And there's things like the newer thermostats that are out there, the learning thermostats, like the ones Nest and Ecobee and others like that, that also have some feedback that teach you when you're in a kind of green operating mode, when you're in a low energy mode. They also have proximity sensors to tell if people are around. These thermostats can also be connected. These thermostats can also give you information and feedback even when you're not there. Some of the other factors to keep in mind when I think about HVAC 101 is there are actually standards that allow you to understand how to do a quality installation. The Air Conditioning Contractors of America, or ACCA, has a standard called QI5, which defines quality installations. Quality in terms of design of the system, installation of the system, and testing of the system. And this kind of standard is great for consumers, building owners and operators, contractors, utilities, equipment manufacturers, HVAC trainers, basically the whole industry. It gets everybody on a common playing field, and kudos to ACCA for putting this material together. So if you're curious about what's in that standard, you can actually download it for free. It's called ACCA QI5, and I've created a short link for that. It would be bit.ly/ACCA-QI5. That's all uppercase letters there. So it's bit.ly/ACCA-QI5. You'll be able to download that quality installation standard. Some of the things we talk about in terms of sizing the equipment correctly involve things like a manual J, thing you're probably familiar with. That's a residential load calculation. Things that are involved there include square foot and floor plan of the residence, sun orientation, the air leakage rate. Now that may ring a bell if you're building science oriented. That's got to do with the blower door test. The amount and type of insulation that's involved in the structure, the number, location, and type of windows, as well as any heat of producing appliances or lighting or any kind of human activity, number of occupants in the structure. All those factors will allow you to develop a correct load calculation to know what type of equipment to be installing. If you want to get a quick picture of what a load calculation might look like, and I encourage people to do this, there's actually a free load calculator. Now, it's not a certified version, but it can give you a ballpark number. You'll find that at www.loadcalc.net. That's LOADCALC.net. And you'll be able to put in your location, the number of walls, ceiling, different types of glass, doors, skylights, basement walls, etc. And it will take a look at the calculation and tell you what the load should be for that structure. Another important factor when we're dealing with air moving, air heating, air cooling systems, that's not present in every situation, but a lot of situations we have ducts to deliver that airflow. So Manual D, that's also an ACCA document that will describe the required airflow to each room in order to keep that load calculation in sync. You take into account factors like the required airflow, air handler location, blower power, length of ducts, duct material type, even the grills in terms of mixing and throwing the warmed and cooled and correctly conditioned air. Now, I've got one quote from a friend of mine who does some teaching in that area. His quote is, "This is rarely used and often not done correctly." So it's sort of a sad state of affairs there, but let's see if we can learn about how to better do duct design. In homes where you have a situation where there's a central return, sometimes closing doors can cause air to be squeezed into or out of different rooms. And sometimes that can be squeezed out. That expensive air can be squeezed out of the house. So that has to be a consideration or a factor in making sure there's the right kind of airflow moving into as well as out of the room to supply and return it. That can have a very big impact on comfort and efficiency. We mentioned ventilation air a little bit ago. There's one standard that actually has specifications for acceptable indoor air quality and ventilation requirements that will lead to that acceptable level. The standard is called Ansi, AHRI, Standard 62.1. Now, Ansi is the American National Standards Institute. It's basically an institution that controls how standards are developed to make sure they're all done uniformly and can be relied upon. AHRI is the American Society of Heating, Refrigeration, Air Conditioning Engineers. The standard, AHRI 62.1, is in the edition of 2016, is the latest edition available. And it's basically for commercial buildings, anything except a residential building. Now, there's an AHRI 62.2 standard that's defined for residential buildings. It's the ventilation acceptable indoor air quality in low-rise residential. 62.1 would cover, of course, high-rise residential, things that are generally considered apartment buildings or commercial buildings, and any kind of workspaces or offices. So these two standards, the committees that are involved with these two standards are doing a lot of very difficult work ascertaining and trying to develop something that can be used to interpret, to define what the correct ventilation rates are to achieve acceptable indoor air quality. It's not an easy job by any means. So ventilation is designed to provide fresh indoor air for occupants, for their health mainly, also for comfort. It also provides dilution for any kind of pollutants that may be inside the structure. And it can also serve to lower humidity, remove odors. And these standards are written, these AHRI 62.2 standards, 62.1 and 2.2 for residential and commercial, respectively. Sometimes strategies for ventilation, there can be several different strategies. One is exhaust only. Now, as we probably know from being building science and HVAC, when you pull air out of a structure, you usually have to replace it. Otherwise, you're evacuating it and you're causing a vacuum to be present. So with an exhaust-only ventilation strategy, the supply air may not be coming from a controlled or known space. And I call that unconditioned supply air or unknown supply air. It's basically air infiltration that will come through the building structure. Some ventilation strategies involve a central fan with an integrated supply that's coming from a known source. And then there's also for tighter homes that have much tighter envelopes, much less air leakage to the outside, you can have a balance system. That means as much air is being pulled out as is being pushed into the structure. So there's two different types of balance systems. One is called a heat recovery ventilator, which involves a heat exchanger, so the air being drawn out by a fan is counterbalanced by air being drawn in by a fan. And there's a heat exchanger, actually, that transfers the heat, so there's no loss of heated energy in an HRV. In an ERV, which is an energy recovery ventilator, we take it up a notch to recovering both the humidity and the heat through a different type of medium inside that ERV that actually controls the transfer and flow of humidity as well, moisture, humidity, as well as the heat energy. Some homes, buildings, residences, offices, commercial places of work often have dedicated exhaust fans pulling air out, things like kitchen hoods. In kitchens, actually, the cooking process can be a major pollutant. There's a lot of research that's going on right now, and we'll probably get some experts in to talk about that. Also, bathroom fans pull out the usually more humid air from inside a bathroom. That can also be used as a ventilation control strategy with different types of timers and controls that actually help periodically pull fresh air in from the outdoors when you have an exhaust-only ventilation strategy. Some of the other factors that come up that are interesting are air distribution, the air mixing, the throw, spread, basically washing the walls of the structures inside the room with heated or cooled air to give that overall ambiance that provides comfort for individuals. There's also filtration that's considered to remove the particulates. There's various types of media filters. You may be familiar with the MERV rating, Minimum Efficiency Reporting Value rating. Now that's actually going to be changing to an international standard shortly. We'll probably have someone on the show, a guest, to cover that topic too. I've actually done some studies in my own home looking at particulates, CO2 levels, carbon monoxide levels, temperature and humidity. And this is also documented very well that there's a correlation between outdoor and indoor air. There's actually some studies that are going on with regard to the reduction of contaminants in indoor spaces that are coming from outdoor sources. So that's going to be another topic we delve into. And I found when I had the IQ monitors hooked up in my home and I was doing cooking, various forms of cooking generate really high spikes at different times of particulate levels. And the particulate levels are those that can kind of get deep inside your lungs and for certain people can cause reactions and sicknesses and illnesses. There's also bio-type particles that can be floating around, as well as VOCs, which are volatile organic compounds. There are different types of air treatment for those, and those actually have been covered in the HVAC school podcast at different times. Additionally, noise can also be a factor for making a comfortable environment. And then just one final note here about AFUE and how would you measure that or tell what that is. AFUE is the sticker, the design standard test that's being done according to a federal standard in a controlled lab condition. Now, that's not the same as the steady state or combustion efficiency, also called the SSE. These are not two equivalent factors. Okay, that wraps up the first episode of the Building HVAC Science podcast. We hope you enjoyed it and you come back to listen next time. We'll be covering a lot of different and interesting topics. And again, if you'd like to follow us on Facebook, our Facebook page is Building HVAC Science. Drop a note, leave a message there. Let us know what you're interested in hearing about and what your reaction is to these episodes. Thanks a lot for listening. We look forward to seeing you next time.
Hey, thank you for listening to this maiden voyage episode of the Building HVAC Science podcast with Bill Spohn. I'm Brian Orr, and I wanted to just welcome you to this podcast and thank you for listening to another show on the Blue Collar Roots Network. Bill mentioned it at the beginning. There are many great shows on the Blue Collar Roots Network. The HVAC School podcast is the one that I created. Then Zach Ciota and Ralph Wolf have the HVAC Shop Talk podcast. Of course, this podcast, Building HVAC Science, and we have many, many more coming up soon. The best way to listen to a podcast is to subscribe via a phone app. So if you have an Android phone, then the best way to listen is either on the Google Play Store, you can just search Building HVAC Science there, or you can use the Stitcher app, which is another great application that you can use on Android. All you have to do is just hit the subscribe button, and then every time a new episode comes out, it will automatically be on your device so you can listen to it. There's a lot of really interesting and emerging technology as it relates to podcast listening. The idea is that you subscribe to all the shows you like, and then you just open the application, and it's like listening to the radio. It shows where you have a new show, and you can listen, and then it just moves on to the next one. And that's a lot of what we're doing here at the Blue Collar Roots Network, is creating a critical mass of content so that there's good content for you to listen to every day of the week. If the device that you have is an iPhone or some sort of other Apple device, even if it's a computer, you can use either iTunes, the iTunes program that you have on many computers out there, or for your phone, you can use the podcast app, which is on every new iPhone that's made. It's looks like a purple radio tower. Click on that and you can download the podcast there. You can subscribe to it, and you can also leave a review. So if you enjoyed this podcast, especially since it's so new, it's really helpful if you can go on there and leave Bill a quick review. Another thing to mention is that all of the high-quality instrumentation and measurement equipment that Bill talks about on this podcast, you can find by going to TruTechTools.com. That's TruTechTools.com. Thank you for listening, and we'll see you next time on Building HVAC Science.